Okay, hello everyone. This is your physics teacher. So because of the recent virus outbreak, actually many of our lesson got cancelled, especially because of the e-learning arrangement and all that. So because of that, in order to help you prepare for your semester 1 test, which involve the earlier term 1 topics, I have decided to make this lesson video to actually go through this piece of homework with you rather than using class time. But before I go through the common mistake made in this assignment, I have to say that I am actually not very happy with your quality of work, because when you are doing this assignment, uh, some of you have realized that you have forgotten, for example, how to answer a KMM structure question, or that you have forgotten what is the meaning of thermometric property. So rather than going back to your previous worksheet and find out what is the answer, you decided to make a guess and let me mark and see whether it is correct or wrong. Now that defeats the entire purpose of this assignment, because when we pick the question for this assignment, we are picking question to check whether you can recall the content or not. And we expect that when you realize you have forgotten the content, you would actually go back to your previous worksheet and find out what is the answer, rather than to just make a guess and get it over and done with. That is very poor attitude. Yeah, by going back to your previous worksheet and find out what is the right answer, or that when you are uncertain you refer back to the previous material, that is a form of revision itself, and we want you to do that. Okay, so I do not want any more of such behavior in the next holiday assignment. Okay, so let's not waste time and go to the worksheet. So this is the worksheet for 1A. Most of you got it correct. Let's go to your 1B. So I know that you won't be able to see my pointer, so I will just use the pink color highlighter to tell you which question I'm talking about. So we are going to skip 1A because most of you got it correct, and we are going into 1B. So here. Okay, for 1B, most of you got it correct. Whenever you mention collision, you need to give me the two key adjectives. So in the remark, if you see ADJ, it means that you have forgotten to give me these two key adjectives. Now, why is these two key adjectives important? Is because you are trying to explain to me why the dust particles are moving constantly and randomly. Hence, the collision must also be constant and random. Okay, now the next thing that some of you make a mistake is that when you are talking about the collision, you have to show me that the active role is actually played by the air particles. So if you are saying something like, oh, the dust particle is colliding onto the air particle, then this whole statement is wrong, because your dust particle is actually passive. It is just hanging there, motionless. It is your air particle that is moving spontaneously, and because of their spontaneous, constant and random movement, they knock into the passive dust particle, and that is what you are observing. You see that the dust particle are moving because of the collision by the air particle. So you have to tell me that it's the air particle that's colliding onto the dust particle. If you still do not understand the difference, then if I punch you with my fist onto your face, can I say that your face collide with my fist? No, right? Your face is the passive role. My fist is the active role, right? I punch you. So therefore, I have to say that my fist collide onto your face rather than your face collide onto my fist. Okay, there's a small detail in the implication when you place the subject. Okay, so therefore that is for your 1B. Okay, let's talk about your 1C. Okay, when you are talking about 1C, for those of you who remember or refer to your previous worksheet, most of you got all the points correct. Just be very careful. Down here, there's a typo. it need not go outside of the cylinder, so you can cancel that. Be very careful, we are talking about the piston going to the left. So if you refer to the diagram, the piston will go to the left. It means that this part here, the yellow part, after you pull the piston to the left, will become larger. So actually when you pull the piston to the left, the volume goes up, and it's like initially I have this and I have 3 particles. Then after, so this is my before, and after I pull the piston, I will now have a larger volume with the same number of particles. So definitely your number of particles per volume will drop rather than rise. Okay, so that one, some of you make the error. Okay, now the other thing is that when you are commenting on the pressure and you want to talk about the collision frequency, you must mention to me the collision is between what object. So if you mention to me it is between dust and air, or that it is between air and air, this is completely wrong. Now the reason is because when you talk about pressure, it is actually the force exerted over a unit area. So what is this unit area? It refers to the wall of the cylinder. And what is knocking onto the wall? It is the air particle, because the dust particle is passive. They don't move. It is the air molecules that is moving. Okay, so there is this a small detail that you need to pay attention to. Okay, for question 2, you need to know how to read the graph. So there is a lot of highlighting. So what I'm going to do is that I will erase it first so that you don't get confused all over the place. Okay, number 1 is that whenever you are getting a graph, you cannot assume that the corner is 0, 0. This is an over generalization. Okay, for your question 2a, this one, like I said, if you have forgotten what is thermal property, please go and look at your textbook. It is in the chapter of temperature. Okay, so I am actually asking you, what is the thermal property if it involves a liquid and if it involves contraction and expansion due to a temperature change. So for this kind of behavior, there is a specific way of describing the thermometric property. Please go to your textbook and find out. I'm not going to tell you. Okay, next is about your calculation. So similarly, if you have forgotten how to do a calculation, please refer to your worksheet 8.3. Now for those of you who have referred to the worksheet and still not sure, this is a short and a very quick way of explaining to you. So I'm interested in the temperature of substance A. Now when you look at substance A, you will find that there is already 2 information given to you. This is one of them. This is the other one. So with this, I will be able to get 2 sets of coordinate, 2012, and the other set is actually 4500. Now what the question wants is that I want to find out what is the temperature, which is here, when my liquid column expand by 32 cm. So it is similar to a math question. When I have 32 here, I want to know what is the temperature over here. So down here, I would have another set of coordinate 32, T. Now since it is a straight line over here, it means that the gradient I get from this point to this point will be the same as from this point, or maybe I use another color, from this point to this point. Okay, so you can compare the gradient. For example, you can do 145 minus 12, 20. This is the gradient between this point and this point, must be equals to the gradient between this point and the point that you are trying to find. So by solving this, you can actually find the unknown T. So I've been telling you that you have to follow the procedure that I'm teaching you, but some of you are very stubborn. You try to use ratio method, whatever method you can, if you are very careful. And I will promise you, I'm going to set something that will trap you. You are going to make mistakes. So if you are really want to stubborn and test yourself, so be it. You want to use your marks to test yourself, okay, go ahead. Okay, but it is very arrogant of you if you got it wrong. Okay, I have teach you the best method. You have to learn. Okay, it is not the time to prove yourself. If you want to prove yourself during practice, you can use a ratio method until it is perfect. Then okay, go ahead and use. I will not stop you or mark you wrong for using it, but I'm going to set a question that will make using ratio method very difficult. Use the gradient method that I just showed you. Okay, the other one, let's go to the other question, part C. Why is substance C not a good candidate for a thermometer? So whenever you are answering such question, the question actually asks you to explain, so you need to tell me the consequence. At the same time, you also need to let me know what is the data that will support your explanation. So in this case, you must first comment on the data, and if you look at the data, let me clean it up. If you look at the data, this is your substance C. You can see that it is a curve. So why is a curve not a very good candidate is because if you look at, for example, I have a 20 cm cube expansion, and let's say I have another one, let's say here is 40, let's say. You can see that actually the although I have increased by the same amount, you can see that down here there's a jump of this much temperature compared to a jump of this much temperature. So it will cause your scale to be irregular. So I have actually explained that in your earlier worksheet, and this is just a revision. So if you are unable to appreciate that, please go back to your old worksheet. I'm not going to spend any more time on this. So how do I phrase this in a concise manner? So whenever you see a curve like that, it means that you have a non-linear relationship. And whenever you mention a relationship, you must tell me it's between who and who. So for example, if sooner or later, let's say someone asks you, are you in a relationship? You have to let people know that you are in a relationship with who, correct or not? Yeah, don't keep it so secretive. It's not BGR. So don't apply your BGR secretive approach to a physics paper. So down here, once you mention it is a non-linear relationship, please let me know it is between what and what. How do I know it is between what and what? Read the graph. It is your axis. Okay. The next thing you need to do when answering question C is that you need to let me know the consequence. So what's the consequence of having a non-linear relationship is that your scale will become will have irregular interval, and please, having irregular interval doesn't mean that it is not accurate. That is not true. Whether it is accurate or not depends on the procedure of you obtaining this graph. And since you don't have that information, you cannot claim that the instrument is inaccurate. But having an irregular scale, you can conclude that it is very hard to read. So that is your consequence and how to phrase your data. Okay, for your part D, most of you got it correct, but for your part E, many of you got it wrong. So I have show you an analogy about sensitive. Sensitive means that how much change you can observe per unit degree C change. Now if you remember that, then let's look at your graph. So for this graph, you will see that here on the y-axis is your temperature change, and here on the x-axis is the observable change that you can see, and you are going to compare A versus B. Okay, so let's say I want to have a temperature change of 12 degrees C. So I will draw a line horizontal to here, and you can see that at here for A, for every 12 degrees Celsius temperature change, I can see an expansion of 20. And at the same temperature change of 12, at B, I will be able to see a number that is definitely bigger than 20. So with the same amount of temperature change, if I'm using substance B, I will be able to observe a larger change. So when I have a larger change, it means that it is more sensitive. So that's why it is B. Okay, as for responsiveness, it means how quick the change occur. And you cannot tell how quick the change occur from this graph, because from this graph, there is no reading on time. and without time, you can't tell whether it is changing quickly or changing slowly. So how do I do that? I need to search for time, and I can see that there's a time over here because it's seconds. So down here, this column tells you how quick the expansion occur, and you can see that for B, it occurred the fastest. Yeah, this one, 80. So that's why down here, the answer is B. Okay, for question 3, I'm very impressed by the class. Most of you got it correct. Okay, for question 4, just some minor mistakes. When we talk about this case, how does evaporation causing a cooling effect? You need to focus on the evaporation process. I understand that our body temperature is higher than the water from the swimming pool, which is at room temp. So naturally, the room temperature water is going to absorb heat from your skin, and that would cause a cooling effect itself. But we know that is true, but we are not going to comment on that because we want to focus on evaporation. Okay, we want to focus on this. So because of that, let's see how we should phrase it. So number 1, in your mind, you should have this mental picture whereby the skin is like enveloped by a layer of water, and evaporation actually takes place on the surface of the water on the skin. So that's why I highlighted over here. So when you talk about evaporation, don't go and talk about, oh, there is random collision, and then the particle can be faster, slower, and you take 3 lines talking about that. That is not the focus, right? So because of that, if you want to talk about KMM and you want to talk about random collision, limit it to 1 line. Okay, so just say that there's random collision, and because of that, there will be some energetic particle at the surface of the water on the skin. Okay, so you need to learn how to phrase it. And this energetic particle will leave, hence your IKE of the water will drop, and then the temperature drop, and as per normal. Okay, then after that is for your part D. Part D, most of you are able to state what are the factors, but you need to tell me, is it getting higher temperature or lower temperature? That is because I have asked you that I want the cooling effect to be more significant. In another word, I want evaporation to happen faster, right? So here I want my evaporation to occur faster. So if you just tell me temperature and full stop, this will be marked wrong. Do you want a high temperature or do you want a low temperature? So please complete your sentence. Okay, for question 5, actually there's a typo over here. I'm very sorry. So this is actually Z. So just remember, if you are talking about a state change, please use the word and. Okay, and both state will occur during melting. Some of it will be solid, some of it will be liquid. That's why it is called melting, right? It has not melted. Yeah. Okay, down here, most of you, I'm happy you all got it correct. If you got it wrong, either you see me or you find your friend. Definitely you need to master this skill. Okay, for your part C, refer to your previous worksheet. It is asked many times. You have to talk about IKE, IPE, bond breaking, and then IKE being constant, temperature is being constant. I have to repeat one thing. Please pay attention. One very important thing. When you are talking about state change, for God's sake, volume change, yes, it is true, but it is not the focus. So stop telling me that the bond, that the particle are getting more and more further apart. Instead, focus on the change in the bonds, the intermolecular bond break or the intermolecular bond form. That is the focus. That's why it is called state change. Okay, so whenever you're talking about state change, focus on the bonds rather than the volume or the distance between particle. It is true, but that is not important. What is important is the bond. Okay, so it's like watching a romantic movie, and then rather than talking about the boy or the girl, suddenly I go and talk about the bench. Yeah, the bench is there, but it is not important. It is the boy and the girl that I want to focus on. So when state change, stop telling me about volume change. I don't want to hear it unless the question asks for it. Okay, for your part D, it is quite straightforward. Just show me that you have the same starting temperature, same melting point, but it will take a shorter time to reach. And of course, with a weaker burner, I took this amount of time. With a stronger burner, I would take lesser time to finish my melting, and of course I can heat it up faster to reach 70. So as long as you show me this concept of using lesser time to reach the temperature, using lesser time to melt, then you will be able to actually answer this question correctly. Yeah, as you can see here, my burner become much stronger at 4000 W. Okay, so with this, I have to say that goodbye class, and that is your physics teacher signing off. Okay, I hope you revise for your test and all do very well. Okay, goodbye. Oops.